66 million years ago, something hit our planet so hard, it ended the reign of the most dominant creatures that ever walked the Earth. A rock the size of a city, moving at 20 kilometers per second, carrying more energy than 1 billion nuclear bombs, a shockwave that leveled forests across entire continents, a fireball that set the sky on fire, a winter that lasted years, maybe decades, and just like that, the dinosaurs were gone, or were they? Here's the thing, that extinction event, it wasn't guaranteed. It wasn't written in the stars. It was a cosmic accident, a random piece of rock drifting through space for billions of years, arriving at Earth on exactly the wrong day. Scientists have calculated that if the Chicxulub asteroid had arrived just 2 minutes earlier or 2 minutes later in its orbit, it would have splashed into the deep waters of the Atlantic or Pacific Ocean. The impact energy would have been dramatically absorbed. The dust cloud would have been a fraction of the size, and dinosaurs? They would have walked away. They'd still be here, right now, on this planet, possibly staring right at you through your window. So today, we're asking the question that paleontologists, evolutionary biologists, and science fiction writers have been completely obsessed with for decades. What if the dinosaurs never went extinct? What would Earth look like today, 66 million years later? Would humans even exist? And if some form of intelligent life did emerge, what would their civilization look like in a world shared with 10-ton predators that make lions look like house cats? Buckle up, because this thought experiment is going to take you somewhere genuinely mind-bending. Part 2, the world that almost was first. Let's get one thing straight, because this is something that drives paleontologists absolutely crazy. When most people say dinosaurs, they picture two things, T-Rex and maybe Triceratops. That's it. That's the whole mental image, and that is spectacularly wrong. Dinosaurs were the most diverse group of large animals that ever evolved on this planet. By the end of the Cretaceous period, there were over 1,000 known species, and scientists estimate we've discovered maybe 30 to 40% of the species that actually existed. The real number was almost certainly in the thousands. You had dinosaurs the size of pigeons and dinosaurs the size of commercial aircraft. You had dinosaurs that were pure carnivores, pure herbivores, and everything in between. You had dinosaurs that were covered in feathers, dinosaurs with elaborate crests and frills and horns, dinosaurs that lived in herds of thousands, and dinosaurs that were solitary apex predators. You had dinosaurs in the oceans. Okay, technically those were marine reptiles, but you get the point. Life in the Cretaceous was extraordinarily rich, and this diversity is critically important for our thought experiment because it means that in our alternate timeline, dinosaurs aren't just the dangerous things in the background. They are the ecosystem. They are the herbivores, the omnivores, the predators, the scavengers. They fill every single role that mammals fill in our world today, and they've had 66 million extra years to keep evolving into those roles. Without that asteroid, the late Cretaceous world keeps spinning. The continents continue their slow drift, sea levels rise and fall, climates warm and cool, ice ages come and go, volcanic eruptions reshape landscapes, and through all of it, dinosaurs, being the extraordinarily adaptable, resilient animals they already were, adapt right along with it. Remember the most important rule of evolutionary biology? Evolution never stops, not for a single generation. Every birth, every death, every predator-prey interaction, every climate shift is another pressure on the genome, another roll of the evolutionary dice. Over 66 million years, the same stretch of time that separates us from the extinction event, those dice get rolled an almost incomprehensible number of times. So what do you get after 66 million years of dinosaur evolution? The answer is almost anything. Part 3, evolution doesn't wait. Let's talk about dinosaur intelligence, because this is where things start to get genuinely unsettling and genuinely exciting. By the end of the Cretaceous period, certain dinosaur lineages were already pushing the boundaries of what we think of as reptile intelligence. The Troodontids, a family of small, fast, bipedal theropod dinosaurs, had some of the largest brain-to-body size ratios of any dinosaur group ever discovered. Their encephalization quotient, which is the scientific measure of relative brain size, was comparable to modern birds and even some mammals. These were not simple, instinct-driven animals. There is strong evidence they were active hunters who used coordination and possibly communication to pursue prey. Canadian paleontologist Dale Russell became famous in the 1980s for proposing the concept of the dinosauroid. He asked a simple but devastating question. If Troodon had continued to evolve for another 60 million years, what might it have become? His answer was striking. He proposed a bipedal, upright creature with grasping three-fingered hands, forward-facing binocular eyes for depth perception, and a dramatically enlarged cranium housing a significantly more complex brain, not human, but humanoid. Something that walks upright, something that can pick up objects, examine them, modify them, something that, under the right evolutionary pressures, might learn to make tools. Now, Russell's specific design has been criticized by many paleontologists since evolution doesn't always converge on humanoid body plans, and there are good reasons to think an intelligent dinosaur might look quite different from his model. But the underlying argument holds up, given strong enough selection pressure. For intelligence over tens of millions of years, the troodontid lineage had everything it needed to go somewhere extraordinary. Big brain to start with, binocular vision, grasping forelimbs, bipedal locomotion that frees the hands, social behavior. These are, not coincidentally, almost exactly the traits that led to human intelligence in our own timeline. Over 66 million years of continued evolution, we could plausibly be looking at dinosaurs that manufacture tools, that build shelters, that communicate through complex vocalizations or even language, that form intricate social hierarchies and pass knowledge between generations, that, in the most extreme projection, develop something we would recognize as civilization. Think about what that means and hold that thought, because we're coming back to it. Part 4. The mammal problem. Here's the hardest truth in this entire thought experiment, and I want you to really sit with it. In our real timeline, the extinction of the non-avian dinosaurs was not just an event in Earth's history. It was the event in mammalian history. It was the entire reason mammals are here, in the forms they are today. Before the asteroid, mammals had spent roughly 150 million years, living in the shadow of the dinosaurs. Small, nocturnal, insect-eating, burrowing, never getting too large, never getting too conspicuous, never drawing the attention of the apex predators that would immediately eat anything that tried to compete. Then the asteroid hit, and in a geological instant, the board was cleared. Every ecological niche that had been occupied by large-bodied dinosaurs was suddenly empty, and mammals, already warm-blooded, already bearing live young, already possessing relatively complex brains, exploded into that void with breathtaking speed. Within 10 to 15 million years, mammals had diversified into whales, bats, horses, early elephants, and, critically, the first primates. The ancestors of monkeys, apes, and eventually us. Without the asteroid, none of that happens. The niches stay filled. The board never clears. Mammals persist, absolutely. They're tough, adaptable animals, and they would survive. But they stay small, they stay nocturnal, they stay in the margins. Every time a mammal lineage starts to grow larger and push into the territory of larger dinosaur species, it gets outcompeted or eaten. The evolutionary ceiling for mammals in a dinosaur-dominated world is brutally low. No large mammals means no large primates. No large primates means no great apes. No great apes means no Homo genus. No Homo genus means no Homo sapiens. No Homo sapiens means no us. In our alternate timeline, humans are not a thing. We never happen. The entire story of human civilization, every war, every discovery, every piece of art, every scientific breakthrough, every language, every culture, none of it exists. It was all contingent on one rock. Let that truly sink in. Part 5. What rules the Earth instead? So if mammals stay small and humans never emerge, what does our alternate Earth actually look like across the 66 million years following the Cretaceous? The sauropods, those impossibly long-necked giants like Brachiosaurus and Argentinosaurus, continue their lineage. Over millions of years, some branches evolve into smaller, more agile forms in response to changing forest environments. Others double down on size in open plains environments, where bulk is protection. They become the ecological equivalent of our world's elephants and giraffes, but on a scale that would make those animals look modest. The ceratopsians, Triceratops, and its relatives, are already showing remarkable social complexity by the end of the Cretaceous. Fossil bone beds suggest they moved in enormous herds. Their complex horn and frill structures almost certainly served social signaling functions, recognizing members of their own species, establishing dominance, attracting mates. Over 66 million more years, this social complexity deepens. You potentially get ceratopsian lineages with sophisticated herd dynamics, alarm communication systems, even rudimentary cooperative defense behaviors. The hadrosaurs, the duck-billed dinosaurs, were already among the most successful herbivores on the planet. Evidence suggests they had complex vocalizations, using hollow crests on their skulls to produce resonant calls. Given more evolutionary time, some branches of hadrosaur lineage could develop increasingly sophisticated communication systems. Not language, but something richer and more complex than anything we see in modern animals outside of humans and great apes and the theropods. The bipedal carnivore lineage that includes T-Rex, Velociraptor, and the ancestors of modern birds continue to diversify wildly. Some go bigger, some go smaller and faster, some go smarter. The ecological pressure to outthink prey that is also evolving drives rapid cognitive development in the most intelligent lineages. The world doesn't look like the Cretaceous anymore. It looks like something completely new, something that has no name in our world because it never existed. Part 6. Living alongside giants. Now let's run the most extreme version of this thought experiment. Let's say that against all odds, some form of bipedal intelligent creature does emerge in this alternate world. Not a mammal, but perhaps an evolved descendant of a small, clever theropod dinosaur that found its own path to complex cognition. A feathered, upright, tool-using animal, the dinosaur equivalent of us. What does their civilization look like? How does the presence of massive living dinosaurs shape every single aspect of how they develop? Agriculture looks nothing like ours. In our world, the agricultural revolution was built on domesticated mammals: cattle, pigs, sheep, goats, horses. These animals don't exist in any useful form in our alternate timeline. Instead, this alternate intelligent species would have to work with what's available: smaller dinosaur species, perhaps some of the more social and behaviorally flexible theropods. The domestication process would be harder, slower, and more dangerous, but it would happen. Humans domesticated wolves into dogs over roughly 15,000 years. Given the social flexibility already present in some dinosaur lineages, domestication was not impossible, just very different. Architecture is completely transformed. Our earliest cities were built to defend against other humans. Walls, fortifications, moats. These were about keeping rival tribes out. In a world with multi-ton apex predators, your walls aren't keeping out rival tribes. They are keeping out animals that could eat your entire population in a week. Every settlement, from the very first permanent community, is engineered around the threat of predation on a scale that has no parallel in our history. The engineering challenges alone would drive technological innovation at every stage of development. Transportation and communication develop under completely different constraints. You cannot simply walk between settlements in a world populated by territorial apex predators. You need speed, numbers, and defensive capability just to move from one place to another. This would push the development of wheeled transport, organized convoys, and signaling systems, early precursors to communication technology, much earlier than they appeared in our own history. Part 7. The civilization of coexistence. Here's the dimension of this thought experiment that I find most philosophically interesting. If an intelligent civilization emerged in a world where massive predators were a constant existential threat, what would that do to their psychology? To their culture? To the values they built their societies around? Think about the role of large predators in shaping early human psychology. For most of human prehistory, we were not the apex predator. We were prey. Lions, hyenas, leopards, cave bears, dire wolves. These animals killed humans regularly, and there is strong evidence in evolutionary psychology that this shaped us profoundly. Our social bonding, our tendency to live in groups, our deep fear of the dark, our alertness to threat, our capacity for collective action, all of these have roots in our experience as a prey species. Then, roughly 50,000 years ago, human technology and coordination became advanced enough that we effectively eliminated large predators from our immediate environment. We became the apex predator, and something interesting happened. We started fighting each other. War, large-scale organized violence, became a defining feature of human civilization precisely when the external predator threat receded. In our alternate civilization, that external threat never recedes. The apex dinosaur predators are always there, always a real, immediate danger. The selection pressure for cooperation, for collective defense, for suppression of internal conflict in favor of group cohesion, that pressure never goes away. It's possible, even likely, that an alternate civilization, shaped by permanent coexistence with massive predators, would be structurally more cooperative, less individually competitive, and less prone to large-scale internal warfare than human civilization has been. That is both a fascinating and a deeply humbling thought. Part 8. The dark side of the scenario. But I don't want to paint this alternate world as some kind of paradise, because living alongside dinosaurs of this scale would be genuinely, unrelentingly brutal in ways that are hard to fully imagine. Population density would be strictly limited. You simply cannot build a city of 1 million people in a landscape that also supports breeding populations of 10-meter carnivores. The math doesn't work. The food competition alone would be catastrophic. A large theropod dinosaur required enormous caloric intake, and a dense human settlement would look like an all-you-can-eat buffet. Every major population center would need to be either fortified beyond anything in our history or located in geography that naturally restricted large predator access. Islands, peninsulas, deep mountain valleys. This cap on population density has enormous downstream consequences. Complex civilizations require population density. Cities are where ideas mix, where specialization develops, where trade networks emerge, where surplus production creates the conditions for science and philosophy and art. If your maximum sustainable population in any given area is hard-capped by predator pressure, your civilization develops more slowly, more painfully, with more setbacks, and collapses as predator populations surge and devastate communities that had been growing. Technological progress would likely be uneven, rapid in areas directly related to survival and defense, much slower in abstract intellectual domains. You would probably see extraordinary early advances in materials science, in construction, in weapons technology, in agriculture and food preservation. But the leisure time required for mathematics, astronomy, philosophy, the foundations of what we call science, would be harder to come by when every generation faces the very real possibility of catastrophic predator incursion. This civilization would be tougher, more resilient, more collectively organized than ours, and it would also be slower, darker, and more consumed by the basic business of survival. Part 9. What the science actually says. Now, let's be honest about the limits of this thought experiment and talk about what the actual scientific consensus looks like. Some paleontologists argue that dinosaurs were already in decline before the asteroid hit. Certain analyses of the fossil record suggest that dinosaur diversity was slowly decreasing in the last few million years of the Cretaceous. Fewer new species appearing, some established lineages dwindling. If this is true, it raises the question of whether dinosaurs could have sustained their dominance even without the asteroid. But this interpretation is genuinely contested. Other analyses of the same fossil record show robust diversity right up to the extinction boundary. And even the scientists who see some signs of decline generally agree that dinosaurs were not heading toward self-extinction. They were stressed perhaps, but still dominant, still diverse, still fundamentally in control of the planet's terrestrial ecosystems. What is not contested is that the world was changing regardless. The Deccan Traps, a series of massive volcanic eruptions in what is now India, were pumping enormous quantities of carbon dioxide and sulfur dioxide into the atmosphere for hundreds of thousands of years around the time of the extinction event. This was already causing climate instability and ocean acidification. Sea levels were fluctuating dramatically. The spread of flowering plants was transforming the structure of forests and reshaping food webs. So our alternate timeline is not a static Cretaceous world frozen in amber. It is a dynamic, changing world in which dinosaurs face real challenges and real pressures, and meet them with the same evolutionary resilience that had already carried them through 165 million years of Earth history. Some species go extinct, new ones emerge, the ecosystem shifts, but the dinosaur lineage as a whole, it survives, it adapts, it continues.